We present ECGLens, an interactive system for arrhythmia detection and analysis of large-scale ECG data. Our system integrates an automatic heartbeat classification algorithm based on convolutional neural network, an outlier detection algorithm, as well as a set of rich interaction techniques. Our system incorporates an interactive analysis framework to support the exploration through three major steps: initial inspection step for inspecting and selecting an ECG segment, an anomaly analysis step for detecting anomalous heartbeats in the overview and temporal view, and a diagnosis step for the identification of arrhythmia in other views. In this video, we demonstrate the application of ECGLens by analyzing a real-world ECG record from MIT BIH Arrhythmia database. The record is slightly over 30 minutes long and contains more than 3,000 beats in total. By observing the selection panel in the database view, the doctor can brush a wave segment based on the QTC value to further inspect the data for anomaly detection. Here, the doctor brushes the segment around 15th minute since the heart rate is higher than normal. The heartbeats involved in the selected segment are projected in the overview, and the original ECG record will be retrieved and displayed in the temporal view. In the overview, the outlier degree is indicated by the size of point. To detect anomaly, the doctor can manually brush a group of highly anomalous points, add or omit some points individually, and then investigate the details in the inspection view. Here, the doctor finds some arrhythmias quickly, like the PVC and ventricular couplets by twirling the slider in the inspection box. Afterwards, the doctor can save the identified disease in the disease view, and the corresponding ECG record can be retrieved in the record view. In addition, the doctor can continue the detection by the recommendation of a category. In this way, the doctor will be able to identify some arrhythmias that are missed in the previous detection. After ranking the heartbeats in the inspection view by their outlier degree, some mislabeled heartbeats are detected and corrected by the doctors for precise diagnosis in the following steps. The detection results in the overview can be retrieved by undo or redo buttons. Doctors can also explore the anomaly and make diagnoses in the temporal view, which displays the original ECG record in time domain. A new glyph is designed in this view to improve the readability and facilitate the comparison of ECG heartbeats. Each glyph is divided into four components, representing the P wave, QRS complex, ST segment, and T wave respectively. The rectangle indicates the deviation of wavelength from the normal value, and the vertical line indicates the deviation of amplitude. A single circle indicates the normal heartbeat. In addition, the background color means the overall outlier degree of a heartbeat. The effectiveness of the glyph is demonstrated by a comprehensive user study. Let's get back to the demo. First, the doctor used auto detection and finds some noisy signals, as well as pre-excitation. Then the doctor quickly navigates the ECG record around the points by comparing the glyphs and finally identify the ventricular trigeminy due to the special pattern displayed by this kind of arrhythmia. If the doctor wants to know the numeric information of the heartbeat to validate their diagnosis, they can click certain heartbeats and get a detailed feature value in the details view. After the identification of the arrhythmia, the doctor can refer to the statistical information of some predefined parameters in the statistical view, like the heart rate or features of P wave. Across all views, the corresponding ECG heartbeats will be highlighted simultaneously in the system, and the two tips will provide instant information for reference. We have presented ECGLens, a novel interactive visualization system for exploring large-scale ECG data and finding anomalous heartbeats, as well as detecting arrhythmia and making precise diagnosis.